In this question, we're asked to actually draw some Lewis structures, and I picked two of them, carbon dioxide, CO2, and NO2+, which was just on a different example that I found on Alex. Learning how to draw Lewis structures is essential for doing these couple of chapters in general chemistry. It's also essential for later chapters in general chemistry too, and organic chemistry, so it is something that's worth your time to learn how to do. So I have this step-by-step approach of how we're going to find Lewis structures, and we're going to start with carbon dioxide. So with carbon dioxide, the very first thing I want to do, or any molecule, is count the valence electrons. So if carbon has 4, it's in 4a, plus 6, I'm going to write that over, 4 plus 2 times 6, which equals 16 electrons. So carbon has 4, there's 2 oxygens, each have 6, it's in 6a, which gives me 16 electrons. Put the least electronegative atom in the middle. You have to remember your trend for increasing electronegativity. Fluorine is the most electronegative, followed by oxygen, followed by chlorine, but oxygen is second, carbon is over here, so it's less electronegative, it's further away from fluorine, so it goes up and to the right. So fluorine's the most, so carbon's here, oxygen's here, carbon goes in the middle. Because it's the least electronegative, it goes in the middle. And we bond it to 2 oxygens, like so. Now, I have used 4 of my 16 electrons, which means I have 12 left. One thing that I instantly notice is 16 is divisible by 2. So if I put 8 electrons around each oxygen, and generally I like to put the electrons on the outside atoms first. You don't have to do it that way, but I generally like to do it that way. I'll notice that I've filled the octet of oxygen, and I've used 16 electrons, because there's 8 electrons here and 8 electrons here, which gives you 16. A lot of times, not always, these numbers are evenly divisible by 8. If that is the case, it saves you some counting time. So putting 8 around oxygen, putting 8 around this oxygen gives me 16 total. Note that there are 2 electrons in this bond, so there's 2, 4, 6, 8 around each. Fill octets. Well, I don't have enough electrons to fill the octets. So if I look at this carbon here, this carbon only has 4 electrons around it. Oxygens are happy, they have 8, but carbon's not happy. One thing that's a bad idea to do is to delete this or erase it or start over or whatever you want to say, and then try again. What you want to do is fix what you have and make it follow the rules. So you want to fill the octets. And then you'll notice that point A under fill octets is use multiple bonds if you don't have enough electrons. I have 16 electrons. I can't fill the octets of all my atoms. My only option is to use multiple bonds. Note, we only use multiple bonds if we need them. I didn't start by drawing this with multiple bonds. I started by drawing it with single bonds. And now I realize I need multiple bonds because carbon's octet is not filled. Doing Lewis structures is answering a series of questions. And it's kind of like doing a puzzle. And just like anything else, if you practice, you get good at it. And with a little bit of practice in this case, goes a long way. So we need to fix this. We have to use multiple bonds because we don't have enough electrons. So what I'm going to do is I'm going to pull those in. That'll put 6 electrons around carbon. I'm going to pull those in, and that'll put 8 electrons around carbon. So now, if I have carbon double bonded to oxygen, there are 2 lone pairs. Maybe I should have drawn the lone pair over here so you could see it was actually that lone pair. But it doesn't matter because I have 3 lone pairs here. I brought one of those lone pairs into this double bond, and there's 2 left. Double bond O, and I have the 2 lone pairs. Same explanation. So this looks good as far as octets go. There's 2, 4, 6, 8 electrons around this oxygen. This oxygen is the same. And 2, 4, 6, 8 electrons around carbon. How do I check if this is the right answer? One of the beautiful things about Lewis structures is you can actually check your answer. And you do that by minimizing your formal charges. If your formal charges are 0 and your octets are full, there's a really good chance that you have the right Lewis structure. So let's take a look. How many electrons does oxygen want to have around it? Well, oxygen's in 6a, it has 6 valence electrons, so it wants to have 6 electrons around it. Remember that we count the dashes as 1, and in several other videos I explain this. So this is 2 electrons, 1 belongs to oxygen, 1 belongs to carbon. So count them as 1 each. 1, 2, 3, 4, 5, 6. If oxygen wants to have 6 electrons around it, and it has 6 electrons around it, it's neutral. Carbon wants to have 4 electrons around it. How many does it have? 1, 2, 3, 4. Wants 4, has 4, it's neutral. This oxygen's the same, so it's also neutral. 2 bonds and 2 lone pairs. This is a great Lewis structure. Now let's look at NO2+, which is just another example from Alex. You only have to do one per question, but I put a second one here just to give us a little bit more practice. So here, we need to do the first thing. Start at the beginning. Count the valence electrons. So how many electrons does nitrogen have? Well, it has 5. Plus, oxygen still has 6, and there's still 2 of them, which looks like 17. However, since it's plus, we do need to subtract 1, which gets us back to 16 electrons. Notice that this is the same as CO2. That's a hint that this Lewis structure might end up looking very similar to the Lewis structure of CO2, because nitrogen and carbon are right next to each other, so nitrogen plus behaves a lot like carbon. It's not always the case, but it is the case in this particular instance. So let's look here. Put the least electronegative atom in the middle. Nitrogen's here, oxygen's next to it. Nitrogen's further away from oxygen than fluorine, so nitrogen is the least electronegative. Nitrogen in the middle. Bond to an oxygen, bond to an oxygen. I've again used 4 of my electrons. I have 12 left. Or, I know that 16 is divisible by 2 to give me 8, so if I put 8, divisible by 8 to give me 2, so if I put 8 electrons around the oxygen, like so, I end up with full octets on oxygen. So far, so good, except I haven't filled octets. And just like before, I need to use multiple bonds if I don't have enough electrons. I can't simply put 4 electrons, 2 lone pairs on nitrogen, because I only have 16 electrons, and that would be 20 electrons, and that's not going to work. So I do the same thing. I make multiple bonds. And I do that twice, because I know that only doing it once will put 6 electrons around nitrogen. Doing it a second time will put 8. So if I put nitrogen here, and double bond it to an O, and then double bond it to an O, I now have these 2 electrons into the double bond, these 2 electrons into a double bond, which goes from 3 lone pairs on oxygen down to 2. So I've lost a lone pair on oxygen. Now, how do I check if I did that right? Minimize formal charges, which essentially means check the formal charges. Let's calculate the formal charges. So if we look at oxygen, oxygen wants to have 6 electrons around it. Count the dots as 1, count the dashes as 1. 1, 2, 3, 4, 5, 6. This is neutral. This oxygen, of course, is neutral as well because it's the same. 1, 2, 3, 4, 5, 6. So they're both neutral. What about nitrogen? Nitrogen wants to have 5 electrons around it. How many electrons does it actually have? 1, 2, 3, 4. If it wants to have 5 electrons around it, and it only has 4, that means that it's missing an electron. Well, something that's missing an electron has a plus charge. So when you look at this, this is the best Lewis structure. If you have to have a formal charge, you want the positive formal charge on the least electronegative atom, which is generally the atom in the middle. There's one major exception to this, which is hydrogen. Hydrogen will never have a positive formal charge in a covalent compound. So therefore, you're not going to put it on hydrogen. But any other atoms, the central atom, and hydrogen is also never the central atom, the central atom is the one that has the positive charge. The outside atoms are where you would put a negative charge, should you have a negative charge. Note that the formal charges must add up to the overall charge on the species. So the fact that this overall NO2 was positively charged let us know before we even started that we were going to have a positive charge on one of the atoms. And it was pretty likely that that positive charge was going to be on the nitrogen.